Right now, somewhere in the sky, two dead stars are falling toward each other. Each one is heavier than the sun, squeezed into a sphere the size of a city, and they've been spiraling together for millions of years. Here's what happens when they finally touch, and it's not a bigger version of an ordinary explosion. Space itself rings like a struck bell. A flash of gamma rays outshines the entire rest of the universe for a fraction of a second. And out of the wreckage comes something almost embarrassing in its familiarity: gold, platinum, uranium. The heavy atoms in your jewelry and quite possibly in your wedding ring were forged in a collision like this one, long before the sun existed. We know because, in 2017, we watched it happen. This is that story. First, meet the objects, because nothing about them is reasonable. A neutron star is what's left when a giant star dies in a supernova, and the core, too heavy to hold its shape, collapses. Gravity crushes it past every material limit. The atoms fold, the electrons are driven into the protons, and what remains is a ball of nearly pure neutrons, matter with nothing left to compress. The result is a star about 20 kilometers across, the width of a city, containing more mass than our sun. The numbers stop meaning anything at this point, so try one anyway. A single teaspoon of neutron star material would weigh billions of tons, more than every building on Earth put together. Its surface gravity is so fierce that the tallest mountain a neutron star can hold is a few millimeters high. Some of them spin hundreds of times a second. Some carry magnetic fields 1 trillion times stronger than Earth's. They are, by any honest reckoning, the most extreme objects in the universe that you can still call matter. Now put two of them in orbit around each other. Einstein's theory makes a hard promise about such a pair: they cannot last. Every orbit radiates a whisper of energy away as gravitational waves, ripples in the fabric of space, and the whisper is theft. The orbit shrinks, slowly at first, for millions or billions of years, and then the physics turns vicious. In the final minutes, the two stars are circling each other hundreds of times every second, their surfaces moving at a good fraction of the speed of light, each one raising tides in the other's iron crust. In the last instant before contact, gravity itself tears their surfaces apart and slings neutron-rich matter into space like mud off a spinning wheel. Then they touch, and for a few milliseconds, the universe contains something new, an object more massive than either star, spinning nearly as fast as space allows, almost certainly too heavy to survive. In most collisions we can model, it hangs on for a moment and then collapses, and a black hole closes over the wreckage like a trapdoor. We're not guessing about any of this, and that's the astonishing part. On the 17th of August, 2017, the LIGO detectors in the United States and the Virgo detector in Italy felt space begin to hum. The signals swept upward in pitch for about 100 seconds, the sound of an orbit dying and then cut off. 1.7 seconds later, NASA's Fermi satellite caught a burst of gamma rays from the same patch of sky. Telescopes across the planet swung around, and in a galaxy called NGC 4993, about 130 million light-years away, astronomers found a new point of light where no light had been the night before. Roughly 70 observatories ended up watching that one dot. The event got a license plate name, GW170817, and it answered questions astronomers had been arguing about for decades in a single night. The mysterious, short flashes of gamma rays we'd been seeing since the Cold War. Colliding neutron stars. It was the first time in history we heard a cosmic event in gravity and saw it in light, and the two messages arrived within 2 seconds of each other after traveling for 130 million years. But the light itself held the real headline. That new dot wasn't a supernova. It was something rarer, a kilonova, the radioactive afterglow of freshly created elements. Here's the problem it solved. A star like the Sun can fuse elements up the periodic table only as far as iron. Beyond iron, fusion costs more energy than it pays. So where do gold, platinum, and uranium come from? Their recipe needs an environment drowning in free neutrons, so that atomic nuclei can gorge themselves faster than they can fall apart, and almost nowhere in the universe is neutron-rich enough. Almost. The debris flung from a neutron-star collision is the purest neutron flood in nature, and as it expands, nuclei in it swell into the heaviest elements that can exist, then decay and settle into the stable ones we mine. The kilonova of 2017 glowed with exactly the colors that process predicts, first blue, then a deepening infrared red as heavy atoms fogged the cloud. 2 years later, astronomers reprocessing the light with the European Southern Observatories instruments identified a specific fingerprint in it, strontium, the first heavy element ever caught in the act of being born. In 2023, the James Webb Telescope did it again for another collision and found tellurium. The teams analyzing 2017's debris estimated it held thousands of Earth masses of heavy elements, including several Earths' worth of gold and platinum alone, from one collision in one galaxy. Follow that thread backward, and it ends on your hand. Before the Sun formed, some pair of neutron stars, the corpses of stars older still, spiraled together somewhere in this corner of the galaxy and salted the nearby gas with heavy atoms. That gas collapsed into the Sun, and the leftovers became the planets, gold included. Much of the gold on Earth, possibly most of it, took that road. Astronomers still argue about whether certain rare supernovae contribute a share, and the accounting is genuinely unfinished. But the 2017 collision settled the headline question. Neutron-star mergers make the heavy elements in vast quantities, and they've been doing it since the galaxy was young. A wedding ring is a strange thing to trace to the most violent event since the Big Bang. Trace it anyway. The metal was cooked in a collision between two dead suns, drifted for eons as dust, spent 4.5 billion years inside a forming planet, and ended up on a human finger, which means you can, right now, reach over and touch the debris of an explosion that outshone a galaxy. The universe doesn't just destroy things when it rages. Sometimes it makes treasure, and sometimes the treasure finds a hand to rest on.